Echo! Man, this thing is huge. You could park a bus in here.
Bill, come on, we got a show to do.
Oh, sorry. Hi, I'm Bill Hupsher.
And I'm Lori Meggs, and welcome to Focus on Marshall. On today's episode, we are standing outside a gigantic oven here at the Marshall Center, and we're going to show you what's baked in here.
But first, we're going to take you to two brand new facilities here at Marshall that are going to help in the development of future spacecraft. One of the greatest things about this job is how you can learn something new every day. For example, I always thought the external tank was built entirely down at the Machine Assembly Facility in New Orleans. Not true. The nose cones are built right here at Marshall. Richard Welch is a supervisor in the non-metallic processing area. And Richard, first of all, what is this material we're seeing here? That is part of the nose cone, right?
The material is, it's a graphite fiber woven into a fabric with a phenolic resin impregnated into that fabric. In fact, I have a small piece here of the material. It's very high strength, very flexible, and it needs to be flexible so that we can put it into the nose cone, form it around some of the corners and cavities that are in the nose cone. The material is actually, the fiber is actually made in Tennessee. It's taken to South Carolina and woven into a fabric, and then shipped to California, and there's a resin is made in New York, and that's shipped to California, and they pre-impregnate this material, and then that material is shipped here to Marshall for us to lay up in the nose cone.
It's really a nationwide effort. So walk us through the steps. What are these guys doing right here?
These guys are actually doing the cutout of each ply. We do a little pie shape so that it fits into the cone itself, and we had done many years of development for this to make sure we got the ply orientation and ply cuts right. They have to be careful of the ply orientation. There's to make a better strength of the cone itself. We lay some up at 0 degrees, some at 45 degrees, some at minus 45 degrees, and some at 90 degrees. And we have a plan that the technicians and engineers follow through step by step to make that happen.
So it's all in the layering.
Yeah.
Well, how much of this material do you use just to make one nose cone?
We actually use almost 300 feet, almost the length of a football field to manufacture. We have 18 plies in the main body of the cone, and then there's 6 extra plies in the very tip of the cone to make sure that there's extra strength there when they mount the spike on in production.
All right, Richard, so what happens after we've cut the pieces out here?
When we get done doing the cutouts of the plies here of the pie shapes, we actually take it over to the cone. We'll go over here and look and lay each ply up into the cone. This is actually under vacuum right now, and between each ply we have to put it under vacuum. When we take it out of vacuum, we'll lay this over, and the operators come in here and do the layup. From there, it goes into the next room behind these doors here, into autoclave, where it's pressure and held under vacuum and heated to 300 degrees to actually cure out the resin that's in the pre-impregnated material.
I know there's a few more steps after this, and that's where Lori comes in.
I'm here with John Sharp, and he is the senior manager for Lockheed Martin for the external tank nose cone project here at Marshall. And John, we've seen it cut and cured. Now what happens?
Well, after cure, it's taken into a large oven that's also here in the National Center for Advanced Manufacturing, and there it's post-cured, and that basically takes it up to a higher glass transition, which makes it more thermally stable. And this brought into this room where it's machined to be able to interface with the external tank down at Machine Assembly Facility in New Orleans. So what you see in this room is a series of drilling and machining tools that the technicians and engineers use to put it into final form and to mount the brackets onto the base of the unit so that it interfaces with the external tank in final assembly in New Orleans.
So John, I understand that each one has a name too.
Yeah, they do. The production crew actually gives a nickname to each of the units, and through the life of the program, we'll have built 54 of these units, so each one has a name. This particular one, Unit 52, is named Betsy.
Any room for Lori anywhere?
Okay, we'll see what we can do.
All right, thanks for showing us around, John.
We're in building 4705 at the Marshall Space Flight Center to talk to Nadra Hadgett. She is a mechanical engineer out here at Marshall. And Nadra, first of all, tell us what it is you do here.
Okay. I work for the mechanical fabrication branch as a task lead for the machining development task.
All right, and today we are here because of a huge project that you've been a part of. The paint's not even dry in this brand new facility. To look at this, a brand new machining tool. This thing is immense. What can you tell us about this?
Well, what you're looking at is a high tolerance, high speed machining tool with 7 axes, and it's just awesome.
Now, can you tell me what exactly machining means? What will happen when we put something in there to be machined?
It's a milling machine, 7-axis milling machine. So what it's going to do is pretty much take off small amounts of metallic or non-metallic material, but it will do it at a high speed. That's what makes it so special.
So essentially something is being sculpted there.
Right, exactly.
What do you mean when you say 7 axis, though?
Oh, 7 axis. This machine has 7 axis, which means that it just can move in 7 different directions. It's the motion. So you have, if you look at the red component there, that's the spindle. There's 5 axes on the spindle. You have the rotary table right here, the turntable. There's 1 axis there. Then you have the headstock and the tailstock, which has the indexers. There's 1 axis there, so if you count them all up, you have 7 axes.
That's impressive. What kind of things will we expect to be seen on here?
Oh yeah, we're going to fabricate dome-shaped components, starting with the comb and bulkhead demonstration articles. We're capable of putting cylindrical components between the trunnions for cylindrical machining.
So it can be turned in many different ways.
Right. It's basically like a rotisserie, I guess, if you think about it, yeah.
A giant rotisserie that could end up in space.
Right.
Okay. Well, thanks very much. We look forward to seeing the first element you put on there.
Thank you.
Bill, it would be so cool to have my name on a nose cone.
I agree, but you know what would be even cooler? The size of the cupcake you could bake in this thing.
Always thinking with his stomach. Find out where we turn up next as we focus on Marshall.